is 10.
Landing a man on the moon and
8,
returning him
7,
safely to the
6.
Earth.
Main engine start.
Right away, Houston.
While not a center like Johnson or Goddard, the contributions to space exploration, and in particular deep space research, make the radar site at Goldstone in the Mojave Desert of California a center for scientific interest. Goldstone has been working for NASA since the very beginning, and it was Goldstone that brought us those first TV images of humans walking on the moon.
Nestled in the remote valleys of California's Mojave Desert is a complex of deep space communications antennas. Without these graceful giants, NASA would not be able to command and receive information from satellites or investigate distant stars and galaxies. The complex called Goldstone has been NASA's switchboard to the universe for over 3 decades. Actually, it is one of 3 stations located at equal distances around the globe, linked together to provide continuous contact with spacecraft. The largest of all dishes, measuring 70 meters across, has been in service for 25 years. Its large ear helps scientists collect data from missions like Magellan, currently mapping the surface of Venus. Faint signals from Magellan travel millions of miles through space and are received by the antenna. Signals that are then amplified, processed, and transferred to the Spaceflight Operations Facility at NASA's Jet Propulsion Laboratory. This is the clearinghouse for all incoming and outgoing information. Ultimately, millions of picture elements are assembled from spacecraft data and transformed into unprecedented views of the Venusian surface.
This one's the oldest, and then it was.
Not all of Goldstone's dishes are pointed at spacecraft. As early as 1962, the 26-meter site used radar signals to detect surface features on the planet Venus. A high-tech antenna was recently added to test new hardware, including equipment that will someday help search for life elsewhere in space. Goldstone is one of the country's oldest and most valuable resources. Tracking first began in 1958 with Pioneer 3 and 4, which measured a second radiation belt around the Earth and helped us chart a course to the moon. Antennas tracked the Ranger lunar probes, and by 1966, Surveyor spacecraft beamed back pictures of the surface.
Forward. 40 feet down, 2.5. Picking up some dust.
Goldstone even brought us live TV
They got
of
the
the
flag
first
up now, and
moonwalk.
you can see the stars and stripes on the lunar surface. The various phases that are burning.
Tracking continued as early Mariner spacecraft visited some of our closest planetary neighbors. In 1977, a pair of Voyagers began a mission that would send back images of worlds we had never seen before. Planets with complex ring systems and their tortured icy moons. Goldstone still receives faint signals from the Voyagers as they head toward the unknown reaches of interstellar space. Goldstone, the premier deep space communications network.
Mars, once thought to be the only solar system planet capable of sustaining life. Optical illusions produced by Earth's wavering atmosphere made many astronomers think they saw canals, man-made riverbeds. To practice for an unmanned exploration of Mars, landing craft were tested on the deserts of Earth. Robot arms would scoop up samples of Martian soil, analyze it chemically, then transmit the data back to Earth by radio. A search for life forms on the planet. But there are no Martian canals. There are, however, tremendous chasms 2,500 miles long, volcanoes larger than any on Earth. These spacecraft sent back hundreds of photographs and data, first in black and white, then in color. our first look at Mars from its own surface, a barren land of rust-colored rocks and sand, and a close observation of the twin moons of Mars, Phobos and Deimos, and a panorama of the Martian sky and landscape. And we found dry channels that may have been carved by flowing rivers in a long distant past. Between the orbits of Mars and Jupiter float the belt of asteroids, chunks of raw rock small as pebbles or hundreds of miles wide. The asteroids may be possible remnants of an ancient planet destroyed by a cosmic catastrophe, but more likely they are bits of matter that never coalesced into a single planet. 2 Voyager craft carried a gold phonograph record of the sounds of Earth, just in case someone was there to hear them. Jupiter, a 500 million miles from the sun, larger than all other planets combined. A globe of swirling gases and constant storms, an atmosphere heavy with methane, hydrogen, nitrogen. Because of the great distance, it took 40 minutes to receive transmissions from Voyager, which were translated into computerized photographs from 500 million miles away. A gigantic cyclopean eye of the striped globe, floating across the surface of the tempestuous planet, a cyclonic welt of electrical discharge and exploding gas, a storm that has continued for centuries. Jupiter gives off more heat and light to its own satellites than the distant sun itself. With its many moons, it is almost like a miniature solar system. And we got our first close look at the largest moons of Jupiter, like Io with its active volcano, Europa, Ganymede, the largest of the moons, a harsh planetoid composed of rock and ice, and Callisto, probably the oldest of the 4 moons observed. The Voyager probe continued on its journey past the ringed planet, Saturn, and its moons. We discovered that the rings of Saturn move in undulating waves, and that the atmosphere is buffeted by strong jet streams blowing at 1,200 miles per hour. Here, Voyager noted the hottest gases detected in the solar system, up to 1 billion degrees Fahrenheit. Saturn's rings are actually millions of particles of mineral, ice, and debris. On through the solar system, Voyager discovered rings similar to those of Saturn encircling the gas giant Uranus. Flew by Neptune, then out, further out. The most distant planet yet discovered, Pluto. 4 billion miles from the sun, Pluto takes 250 years to make only 1 orbit. From here, the sun is only a bright speck in a solid black sky. If the Earth were the size of a golf ball, the sun would be a globe 9 feet across and 1,000 feet away. The nearest star system, even on this vastly reduced scale, would be 40,000 miles away, 5 trillion miles in real terms. Yet our sun is only one of 100 billion stars, immensely distant from each other, yet bound by the invisible force of gravity, all revolving in intricate spirals around a central core, the Milky Way. And recent discoveries indicate that perhaps 90% of the matter in the universe cannot even be detected by instruments we currently possess, an entire shadow universe within our own. Drifting through the galaxy are the nebula, clouds of gases wider than our own solar system. Floating through space and shining with the reflected light of the stars they pass, or obscuring the light of what lies beyond them.